In this video, I'm going to walk you through the process I did to Dockerize my application. I'm building this application, a real world professional application with all the pieces, and I'm Dockerizing it, right? Initially, it was just running on my laptop, just directly on the host, and I modernize it by containerizing it in Docker container. So this is an opportunity to see Docker being used in the real world. So I finished Dockerizing the whole thing, and I wanted to create this summary video explaining what I did, the issues I faced, and the learning moments. There are a lot of things we learn while we work on real applications. So if you ever work on Docker, this is going to be a really good video for you to see it being applied in the real world. I documented my entire process, a couple of hours to actually Dockerize the entire app. And that is part of my community. If you join my community, you will see the whole video. I'm just documenting everything I do for this particular application and a bunch of other projects. I teach ST, software engineering in test, for the modern AI world. So this application has front end, back end, and database. So the way I went about doing it is first we Dockerize the front end, then we Dockerize the backend, then we Dockerize the database. I didn't want to do everything together because that's going to be complicated. It's better to do it a small piece at a time. And I used AI to do this. Of course, I'm using Cursor AI, the IDE, to do this. So the first thing we're going to talk about is Dockerizing the front end. So as you can see here in Docker desktop, I see the application running all three services. So the application is called DoroSocial. I just named it to DoroSocial. And you can see here, there is one application, DoroSocial, and under it, there are three different containers. The backend container, the front end container, and a MySQL container. So if we just look at the front end, if we just click on here, it just opened here. I'm just going to move it right here into this monitor here. This is the front end of my application, right? It's an application to keep track of social media content. Whenever I create some content, I track it here, and I'm going to make this a SaaS so other people can use it. It actually auto generates videos and things like that. There's a lot more capability. I'm doing a build in public, so hopefully you're following what I'm doing with this application. If not, make sure you subscribe so you can follow me build this application from the start all the way until I make it available to the public. So this is the application. This is the backend. And as you can see, it is running in Docker container. So first, let's talk about how the application works so you can understand what does it mean to take an application and move it to a Docker container, okay? You have to understand how the application is architectured for you to appreciate Docker. Docker is just really amazing. If you do not know Docker and if you are in tech, you definitely have to take advantage and just learn Docker. And I just published a 3-hour Docker course. Completely everything you need about Docker is right here on YouTube for free, 3 hours long. So I'll put the link in the description. So just learn Docker. You have to learn Docker. You can't do anything in tech without knowing Docker. It's one of the hardest things out there. All right, so let's go look at how the application actually works. So this is the typical application. A typical professional application has three different things. You have the front end, right? Let's look at this. This is the front end. When you're interacting with the app, you're basically interacting with the front end. Then you have the back end, which is the brain. A lot of the thinking, a lot of the calculation, everything, all the logic, everything lives in the back end. Yes, the front end is the stuff you see, and the back end is what gives you all the information. Then most applications use some kind of database. I'm using MySQL database. So the way it works is the front end will talk to the backend, right? Let's say you go to this page, right? All this content here, it comes from the backend. This is the front end. The front end say, hey, for this particular user, give me the information. And the backend gets the information from the database, right? So front end talks to the backend talks to the database. Now what we did is we take the front end first and we put it into a container. So a container is basically another little computer. So we're going to do this and we're going to color it red so we can act like this is a container, and we're going to add a text right here saying container computer, right? Well, I don't want to say computer. This is the Docker container. Let's just call it Docker container. So a Docker container, you can visualize it like its own little computer. So when you run a container, what you're doing is you have your main computer, which is the host. Then you're going to take another computer and run it on there. That's how I visualize Docker. I visualize Dockers as their own little computers living inside of a bigger computer. You can control its own environment, its own little thing. So that's what we did here. So one of the challenges, one of the learning moments here, when you're running the application locally without Docker, let's say I don't have Docker here. Let's say I don't have Docker. When I'm running this, the way you connect to the backend service, the address is going to be localhost. You're going to use literally the word localhost or 127.0.0.1, right? Because you are on the same computer. The front end is on the same computer. The backend is on the same computer. So when you talk to the other service, you need to know the address. Where is it at? And it is in localhost. So you're going to use localhost. Now, when you put it inside of a container, that little computer here, when you say localhost is right here within this computer itself, within the container itself. Because the container acts like its own thing, right? So its own computer. So if you're inside the computer, inside the container, like you are here with the front end, and you say, connect me to localhost, it's going to try to connect you to the localhost inside there. But your backend service is not in there. Your backend service is outside the container. So localhost is not going to work. So that's one of the number one lessons. If you are inside a container and you try to connect to localhost, that localhost is going to be within the container. So if you want to talk to it outside the container, you will have to use a special address like this, host.docker.internal. So that's one thing you have to do. That's one of the first challenges, right? I knew this, but the AI just didn't update it automatically when I created the Docker file. So that's one thing. And later on, when we put the backend into the container, the backend needs to talk to the database. And again, outside, the backend is using localhost because the database is also here. Everything is on my computer right now before I Dockerize it. Then we're going to take this into here, into a container, into its own little container. So to talk to the computer, the stuff that's outside, it has to use this guy here. Okay, this host.docker.internal. So that's the number one thing you have to know how containers work. That's one of the first challenges. So just to see how I was able to Dockerize it, let me put all my apps here and go to cursor. So the first thing is the front end. So the way the app works, I have the main folder, I have a backend and front end. There's a bunch of other supporting stuff, of course, especially locally. Now inside the front end, there is Dockerfile. So the process here is I just came to cursor and I said, hey, this is the application. Go ahead and Dockerize this application. So cursor just literally decided what Python to use. It created the entire Docker file. Then I review it and make changes. For example, it wanted to use Docker 3.9. I asked it, hey, let's use a more latest Python. Right now there's like 3.14 out, but 3.12 is pretty stable. So we're going to use that. So we're going to use 3.14. We're going to create a folder, doing some Python stuff, some Flask stuff. So the front end is Flask. So the way the application is, the backend is FastAPI, front end is Flask, and the database is MySQL. So it created the Docker file, right? If you know Docker, this is clearly, you can read this, what it's doing. So it basically installs dependencies, then installs the dependency for the application itself, copies all the code, exposes the port, adds a health check, and it basically starts up the app. When you run this container, when you run this image, it basically starts the app. So it created the Docker file. That's the only thing you have to do. So the front end is one of the simplest one. So we created the Docker file and we created an image, we ran a container. When we run a container, we ended up exactly with this situation. We have one container here, right? Let me make this a little smaller to make room. And we ended up exactly with this situation. We have a front end running in Docker, connecting to the backend service, and the backend service connects to the MySQL database. And we have to use this. That was the first challenge we had. The next thing is to go ahead and Dockerize the backend. So I did that. And again, I came to the same thing, cursor. I'm like, okay, let's go ahead and Dockerize the backend service of this application. And the backend service, the same thing. It created a Docker file. I asked it to use 3.12. It's very similar. It's just a little bit more requirements here because of what the application does. Remember, the backend is the brain. It does a lot of processing, auto-generating videos, it runs AI and things like that. So there's more requirements here. Like for example, FFmpeg is a video editing software, a really popular one. So it did all that and it created the Docker file. Health check, exposes the right port and everything, right? So the Docker file is created. Then we run a container. At that time, again, we have to make changes. So the Docker file, there is this env file that it uses to get, not the Docker file, the backend. There's a .env. It has all the service, right? So for example, when you look at this here, this is the connection to the database, how it connects to the database. And it's connecting through localhost. Again, don't get excited because you see credentials here. You never show credentials. I'm doing this because this is local. I'm using MAMP for my database. MAMP is a great way to run database. And that is the default password and user, root. So when I deploy to production, the whole point is at the end, I'm going to create a CI/CD, right? Make sure you follow so you see the process. I'm going to use different users and everything, of course, right? Security is the most important thing. But here, the configuration is using 127.0.0.1. So it's trying to connect to the local version of the application. That's not going to work So I had to create another one for the Docker version, .env backend Docker version, where instead of connecting to 127.0.0.1 or localhost, it's connecting to this spatial link or URL, right? So when I run the application in Docker, I have to give it this environment variables. I have to tell it, hey, use this environment variables. I have credentials here, the Google credentials, API keys for Blotato, and API keys for OpenAI. All of this I have to change because now it's on video. Like the worst thing you can do is put credentials on video. You never put credentials on video and you don't put it into Git. You don't check this in. This .env file, it never gets checked into GitHub. I have to store it somewhere else, okay? Because it has 6 credentials. This is literally a credential for DigitalOcean, which we'll talk about in a little bit. There should be an OpenAI credential somewhere here too. Blotato is a service that I use to publish to different platforms. This thing has an automatic channel where it actually generates a Python tutorial videos and literally every day just post to all over the social media. That is part of this app, and I'm actually running it, but running it locally, and I'm working on as part of this whole process, I'm working on doing it in the cloud. So going back to the Docker part here, I have to use this host.docker.internal. So what happens after that is, let's go back to our drawing here. Now the backend is also in a container. So I'm going to copy, paste this. Okay. So the backend moves into the container now. Okay? So now both front end is in a container, backend is in a container, and then the front end now can talk to the backend with the container name because they are both Docker containers and they are on the same network. I'll talk about that in a little bit. They're in the same network. So now the front end, when it talks to the backend, it doesn't have to do this. It cannot do that. It cannot use host.docker.internal. It cannot use localhost either. It's going to use either the IP address of this container or the network name. Now, Docker automatically is going to put them in the same network. But when the backend is trying to talk to the database, because the database is still outside, is going to use host.docker.internal. Okay, that was the other challenge that we faced. Now, as soon as I did this, front end is running in Docker, backend is running in Docker, the database is still on local. The application, when I'm using it, when I go here and navigate, everything is working fine. The data, the items actually show up and everything. But when I try to generate a video, this thing generates a video. I can just go here, generate. This one is carousel. You can create a carousel too. But I can create a video. So when it generates a video, it creates these video files and it stores them. Where does it store them? It stores them locally. That's how the application is designed, right? Not a great design, but when I first initially designed it, it was just for me. I did not plan to make it a SaaS, but as I'm building it and it's growing and it's really useful, so I'm like, man, other people can take advantage of this. They can use this, so I can turn this into a business. So let's see what happens. I mean, I'm still using it. I'm going to use it every day, but I'm going to make it available. So what happens is, when you have the backend on your computer here, when it stores the data, when it generates a video, that video gets stored. It gets stored on my computer, and then it gets published, and I can move that file into Google Drive, wherever I want to store it, right? So that works just totally fine. But when you're in a container and you store the data locally, and every time you have a new image, every time you make changes, the whole point of containers is when you make a change, you get rid of the container, you start a new container, right? You build a new image, you get rid of the new container, you start a new container with a new image, right? That's the whole point. Let's say you're working on the code, you're making adding feature, fixing bugs, whatever you're doing, you make any kind of change. The whole point is when you make a change, you build a new image. You build a new image, you create a new container. And containers are designed that when they're gone, they're gone. All the data is gone. So when the backend service runs and it builds an application, or builds a video, and it gets stored in that container, next thing you know, the container is gone, the data is also gone. So that's when volumes become really important, right? You cannot really do anything meaningful with Docker without volumes. That's how you make data consistent, right? Persistent, that's the right word, persistence data. So when you create file in the container, that file actually gets created on the host. So in here, the big box is my computer. The little box is the container. When I create a file inside of here, it is actually getting created in my computer. So when I get rid of the container later on, the file still remains the same. So at this point, it was my chance to even more modernize the application. So instead of storing data on local, I want to store them on a remote server. So I'm like, why don't I, since it's going to be a SaaS, now I have a mindset of becoming a SaaS, making it a SaaS, not just my own personal project. So I need to do a more professional way of storing the files. Whenever a video gets created, where do I store that? So that way, I want to store it in a cloud. So Amazon S3, AWS S3, or there is DigitalOcean Spaces. It works just like S3. So for now, since I'm going to deploy everything to Spaces, DigitalOcean Spaces, I figured why not just do everything in Spaces in the same ecosystem, and then later on I can migrate it to S3. And the code works the same. The code that I'm going to use it to Spaces, to upload to Spaces, called Boro3, is the same code you will use for S3. So I implemented that. I just wanted to mention this here. When you're Dockerizing it, you're going to have to make changes to the application most of the time. Not always, but the way the application works is not optimized for Docker. Right now, dealing with volumes, especially when I have a remote server, when the application itself is running on a remote server, and now I have to store data on the server and have to pull the data and stuff, it's just going to be complicated. It's going to be more work. So I implemented a professional way of storing data in the cloud. So at this time, I went and actually made changes to the application itself. Okay. So the last thing I needed to do was, everything's working at this point, the database. The database is a little bit more tricky. For the database, we have to use volumes. There's no way around that, right? Because data gets stored. So we don't need to create a Docker file for the database unless you want to customize it, because MySQL itself, they give you a Docker image, the official Docker image. So we use the official Docker image, and we basically just create another container for MySQL. Let me make this a little bit smaller. Yeah, so we just literally take this MySQL and just created an image. Now all three, the front end, the back end, and the database, they run in a container. And the way you coordinate that is with Docker Compose. So let's quickly look at the Docker Compose. So here inside of the root, so remember we have a Docker file in the back end, we have a Docker file in the front end. Then inside of the root of the project, there is a Docker Compose file, and I have the dev version, the prod version. On dev version, I have to mount volumes. So because when the application is running, I want to be able to make changes to the code, right? And still run it in Docker. So you use volumes. So every time you make a change, the change gets applied right away. You can see it right away. So that's one of the purposes of volumes when in development. So I used different YAML file for dev and for prod. But when we look at the base, so there is three services. There is a MySQL service, there is a backend service, and the front end service. Okay. So all I do is one command. When you go there and you say Docker command up, that's a command, it's going to start all the three containers. It's going to create this network called DoroSocial network, and all the containers are in that network because they can talk to each other. So the front end can talk to the back end can talk to the MySQL without you having to give it that URL, specific URL. It can use a network name to do that. So that's pretty much all you have to know, right? Docker Compose allows you to run three containers at the same time. That's why you see when I open Docker here, you see DoroSocial. You have the backend. It shows it as like one app, but inside of it there are three containers: backend, front end, and MySQL container. And that is because of the three services here. When you look at the MySQL service, we're using an official image. We give it a name. We got some environment variables for credentials, ports, and everything else. Same thing with the backend. For the backend, we're going to use our own image, right? We're going to basically tell it that the name of the image. The name of the image is the same. We're going to give it the tag, special type, because every time you build it, you're going to create a new tag. You're going to create a new version every time you need a new image. So you want to deploy the latest one. So that's going to be very relevant when we get to the CI/CD part. Very, very relevant. Like the whole CI/CD works because of this. So make sure you give me a subscribe and follow along to see the CI/CD part. And if you want to see exactly raw recording of me working on this, right? It looks like there are some changes I needed to accept. Go ahead and join my community. It's completely free for 1 month. It's not just about watching me work stuff. It is a training. It's a full training for ST, software engineering test, QA automation. If you want a career as a QA automation, and I'm doing like a hard left towards AI. Everything I'm doing is going to be AI. So go ahead and join me. You get to watch all of my process for this particular application, but then other projects that we work on, that you work on. This one is just watching me. I'm not giving you the code, but I have a bunch of other projects where I give you the code and you're actually building with me. So hands-on training. So that's where I'm at right now for this app. The app is running, as you can see. It is fully Dockerized. The next thing I need to do right now is create the pipeline, right? Right now, still running local. It's Docker, but still running local. but I need to run it on a remote server. So the next updates are going to be me working on that, me working implementing CI/CD. I'm thinking about GitHub Actions and DigitalOcean. GitHub Action for the CI/CD, DigitalOcean for the actual hosting. So make sure you follow along. If you have any questions, let me know. If you need help with your project, if you're working on an app and you need help with this backend setup infrastructure stuff, feel free to ask me. I'm very happy to help. I'm very happy to learn with you. So hit me up and let me know. I'll see you on the next one. If you are curious about Docker, if you want to learn Docker, make sure you check out the free course that I published, a 3 hours complete tutorial on Docker. Right? Check that out and let me know if you have any questions.